So let's get into discussing the relation between the features of a function f and its derivative. So there's two things that we want to understand in this unit. And first one is that a continuous function may fail to be differentiable, but also that a function that is differentiable at a point is continuous because the derivative exists there. So the tangent line exists at a point of tangency there. So we have to think about it's differentiable if the slope or the slope of the tangent line is the same from the left and from the right side of our value. So here are four examples of functions that are not differentiable at x naught, and we want to see why it isn't. So for our first example here, we can see f prime of x naught does not exist because f of x is not continuous at x naught. We can see it has a jump discontinuity there, so therefore it cannot be differentiable. Now, if we're looking at number 2, this has a vertical slope, so f prime of x naught does not exist because f of x has a vertical tangent line. Moving down to number 3, now we have a continuous function, but what do we see here? The slope is moving up around this side and moving down on this side. So f prime of x naught does not exist because the limit as x approaches x naught from the left of f prime of x does not equal the limit as x approaches x naught from the right of f prime of x. So the slopes of the tangent lines are not the same. And you'll notice that 4 is a similar example when you have two concave ups around a continuous point. That's going to create a derivative that does not exist there, even though it's a continuous function. And it's the same reason here. The limit as x approaches x naught from the left of our derivative does not equal the limit as x approaches x naught from the right of our derivative.